Welcome back, my friends. So far we discussed the concepts of limit. Basically we had an introduction to limits, and then we discussed how we can identify indeterminate forms of limits, and we had two videos on basically solving indeterminate forms of limits using algebraic simplifications, and then we discussed limits at infinity, and we covered three different cases of limits at infinity, including limits of polynomial, limits of constant function, and finally limits of rational function. And today I'm going to continue limits at infinity, and my focus is going to be on trigonometric function, exponential function, and at the end we will see a square root function. So if you want to review those topics, you can watch our previous videos, but for limits at infinity and trigonometric functions, basically exponential function and the last one is square root, this is actually the right place that you have to watch. Okay, let's start with the first one, which is the trigonometric function. For the trigonometric function, we have to look at the function first and then see what type of property we can use, and then basically we can understand what would be the answer at the end. Okay, let's look at this example. On top we have x cubed plus 2, and on the bottom we have the sine of x, and x is approaching to infinity. As you know, for any limit, the first step is to plug in the value that we're approaching to it. So if we plug in infinity here, the answer is going to be infinity cube plus 2 over sine of infinity. Okay, so if we look here, we know that infinity cube is a huge number, so infinity cube plus 2 is going to be a huge number. But what is sine of infinity? Because as we look at the sine of basically sine of x, it's a number between -1 to 1, and basically it is a periodic function, so we cannot say it is -1 or 1. So it's hard to judge what is actually to evaluate the value of sine infinity. It can be -1, either -1 or basically 1, or any number in that range, which means that on top of this function we have a huge number like infinity, but on the bottom we don't know what is the answer. So it is not going to be either 0, -1, or whatever. So we don't know what is sine of infinity for this case, and it means that this limit doesn't exist. So we have to write DNE. Okay, so as you noticed, for this problem, what we did was looking at the property of sine of x. So, and we know that, okay, sine of x is a periodic function between -1 to 1, and based on that we decided, okay, this function cannot have an exact value for this case, so at the end this limit doesn't exist. Let's look at the other example that I have here. So on the top we have sine x cubed over x squared when x is approaching to infinity. Okay, for here we have another property, another interesting property, and anytime that you deal with this kind of rational function based on sine x over something, you have to use actually this property. So the limit of sine of, let's say, theta over theta when theta is approaching to infinity is equal to 0. Okay, and this theta, we have to make this theta, and we have to reach to the same basically variable on the top, on numerator, and on the bottom, denominator. And based on that we can use this property that we have discussed. But don't be confused with the other property that we had, and that was the limit of sine of theta over theta when theta is approaching to 0, which is equal to 1. So the difference is here, it is approaching to infinity, the answer is going to be 0, and the other one, basically, it is approaching to 0, and the answer is 1. So what I'm going to do in here, I have to see how I can make basically this form within this function in order to use that property. And if we look, okay, we have the limit of basically sine x cubed over x squared, and I have to make x cubed on the bottom. So what I'm going to do is, okay, x is approaching to, let me make it beautiful. So, sorry. So we have the limit of sine x cubed over x squared, and x is approaching to infinity. Okay, so we have x cubed on the top, we have x squared on the bottom, and we have to make x cubed. So the easiest trick is multiply both top and bottom with x. So what I'm going to do here is, it's going to be the limit of x times sine x cubed over x squared times x. So the result when x is approaching to infinity, and that would make x times, I just forgot the limit, sorry. So we have to put the limit here. It's going to be x, the square root of sine x cubed over x, basically x cubed. Okay, so what we have here, and x is approaching to infinity. So if we look in here, we have the variable of x cubed inside the sine x, and we have x cubed on the bottom of that specific function, which means that if we look at this function individually, when x is approaching to infinity, that limit is going to be 0. Okay, so this limit is going to be 0 when I plug in infinity in there. And the properties of multiplication, so we have x times sine x cubed over x cubed, and this is the property of multiplication. So what we have here, instead of x, we just plug in infinity, and infinity times 0, a huge number times 0, the number can be anything, it is going to be 0. So the answer, the whole answer of this problem is going to be infinity times 0, which is going to be 0. Okay, easy. We just use that trick in order to solve this problem. Okay, let's look at the other case, which is exponential function. For exponential function, usually we deal with exponential function actually. So we have e to the power of something, yeah? So here we have e to the power of minus x squared, and x is approaching to infinity. So if we plug in infinity here, what we will see? Okay, so the first thing that is x approaching to infinity, so it's going to be e to the power of minus infinity squared, yeah? So infinity is a big number, and if you actually power a number with a big number, it's going to be a very big number, which is again infinity, yeah? So but what we have in here, it's in the form of 1 over e to the power of x squared. Basically we can write it in that form. X is approaching to infinity. X is approaching to infinity. Okay, let me plug in infinity now instead of x. So it's going to be, sorry, it is going to be the limit of 1 over e to the power of infinity squared. And e to the power of infinity squared, it's a huge number. Therefore, I would say it is infinity. Therefore, 1 over infinity is going to be 0. So any number that we have, basically, and underneath we have infinity, the result is going to be 0. Let's look at the other one. We have e to the power of x squared. Okay, e to the power of x squared, and x is approaching to infinity. It's going to be the limit of x approaching to infinity, e to the power of infinity squared, which means this is going to be e to the power of a very big number. So but it is actually e to the power of infinity squared. So the answer at the end for us is going to be infinity, because it is going to be e to the power of infinity squared, a huge number again. Okay, that is like not that much complex, but you will see like the use of like exponential function and the fusion of that with other sort of basically forms that we have seen so far. Okay, let's look at the third one, which is a square root. For the square root, it is like, again, we have a square root function. It can be on a fraction form, or it can be like a square root minus basically another term. But here what I have is a square root of 4x to the power of 4 plus 2x over x squared plus 9, and x is approaching to infinity. Okay, what we have to do for this problem, if I plug in infinity there, the result is going to be infinity over infinity. Yeah, so let me do it easily. So it's going to be, let's say, 4 times infinity to the power of 4, sorry, 2 times infinity over infinity squared plus 9, and this is going to be infinity over infinity, which is an indeterminate form. But how we can solve this? For this kind of problem, when you are looking at some sort of a square root over another function, you have to look at the highest order term that exists inside the function. If you look, the highest order in here is x squared. Yeah, so the x squared is the highest order, and we almost have the same situation at top, because we have x to the power of 4, and when we take the square root, it's going to be x squared. The next step after here, we have to actually divide both top and bottom by x to the power of 2, or x squared. Okay, so the first step is going to be that. So what I'm going to write is going to be the limit of 4x to the power of 4 plus 2x over x squared, and then x2 plus 9 over, then what we have in here is x squared, and the limit when x is approaching to infinity. Okay, for the denominator it is easy, because we can easily write it as, let me continue with that. So we can say, okay, this is going to be 4x to the power of 4 plus 2x over x squared, and then on the bottom what I would have is limit approaching to infinity. What I would have is x squared over x squared plus 9 over x squared. Okay, but how we can put this x squared, actually how we can sneak this inside that square root, what we can do for that? Remember this, whenever we have like x squared of something, we can put it inside that square root, but this should be powered up to, so it's going to be powered up by 2, because we are putting it inside a square root. Yeah, so this equation will be converted into the form of the limit of x approaching to infinity, and then what I would have on top is going to be 4x to the power of 4 plus 2x over x4. Yeah, and then it is going to be on the bottom, it is going to be x squared over x squared plus 9 over x squared. Okay, so we can actually convert now the bottom part into the form of the limit of x approaching to infinity, and then the limit of 4 x4 over x4. Let me rewrite it in a better way. So it's going to be the limit of 4 times x to the power of 4, x to the power of 4 plus 2x x to the power of 4 over 1 actually plus 9 over x squared. Okay, x to the power of 4 over x to the power of 4 we have on the top of this function, and x is approaching to infinity and we are inside a square root. Assume that if it was x approaching to negative infinity, that x to the power of 4 over x to the power of 4 will actually generate a negative 1 for us, because remember that if we have minus 2 squared, it is going to be 4, but when we actually do the square root, it is going to be 2. Usually we remember 2 for that, but it can be minus 2 or 2. But the problem says x is approaching to positive infinity, which means that we are in a positive region. Therefore, x to the power of 4 over x to the power of 4 will generate a positive number when it is inside the square root. But assume if it was basically in negative region and x was approaching to negative infinity, we would have at the end a negative sign, or negative 1 basically, which is going to be a sneak out from the square root. So what I'm going to write now, it's going to be a square root of 4 plus 2, so this is going to be cancelled out, and 1 will be generated, 2 over x cubed the limit, and x is approaching to infinity, 1 plus 9 over x squared. Now it's time to plug in infinity there, yeah? So if you plug in infinity instead of x on the top, it will generate the limit of x to the infinity 4 plus 2 infinity cubed over 1 plus 9 over infinity squared. Yeah, so we have a very big number on the bottom, on basically in denominator of both fraction. So 2 over infinity cube will generate 0, 9 over infinity squared will generate 0. So at the end, the answer is going to be in the form of the limit of the square root of 4 plus 1. So sorry, it's going to be a square root of 4 over 1, and the answer is going to be 2. Okay, these steps were pretty clear. What we did, first we look at the highest order term in the function, and based on that we divided both top and the bottom with that highest order, and then we moved step by step to make actually to generate what we want from this limit. Okay, we covered 3 forms of actually limits at infinity today, and basically we are done with this concept, limits at infinity with different forms of function. So in our next videos we will cover many examples based on different concepts that we have seen so far, and those examples are going to be extracted from exams. So stay tuned for those videos and please subscribe our channel.